This question is a diffraction question. It looks like a fairly standard diffraction grating question. So if we're talking about diffraction grating, we're going to be using n lambda as d sine theta. And then hopefully we'll just be substituting these values in. So diffraction grating has 500 lines per millimeter. We're looking at the third order spectral line, angle of 60 degrees. What's the wavelength of the light? So we're using this to find lambda. As is common, we're told how many lines per millimeter. We're not actually told the line spacing. So 500 lines per millimeter. We're then asked. We then need to find out how many, what the spacing is between the two lines. So 500 lines per millimeter. We can calculate what that means in terms of how far apart they are. So 500 lines per millimeter would mean that it's 1/500th of a millimeter is the spacing. So 500ths of a millimeter gives me 1/500,000th. So D is 2 times 10 to the -6 meters. Then the order is the third order. So I know that n is 3. So I'll get lambda on its own. I'll rearrange for lambda. I've got d sine theta over n. So therefore, 2 times 10 to the -6 sine of, check the angle, 60 degrees, divided by n, which is 3. And then I should get something that looks like a wavelength. So multiply that by sine of 60. And then divide by 3. And I get 5.77 times 10 to the -7. Even if it's not a multiple choice question, that's fairly reassuring because I know that's the sort of wavelength of light, and that will correspond to 577 nanometers. Just to show you, I've got that value. I can use the ENG button and it will convert it into nano for me, so 577, so I don't make any mistakes. A common mistake is to go the wrong way. So I get 577 nanometers, which corresponds to answer B.